YouTube channel. This is Pooja pursuing BE in Sri Venkateshwara College of Engineering, studying in semester 3, section BrahMos, course name Network Analysis, course code BEC 304. In this video, we'll be seeing about two-port network, a pair of terminals through which a current may enter or leave a network is known as a port. A port is an access to the network and consists of a pair of terminals. The current entering one terminal leaves through the other terminal so that the net current entering the port equals 0. There are several reasons why we should study two ports and the parameters that describe them. For example, most circuits have two ports. We may apply an input signal in one port and obtain an output signal from the other port. The parameters of a two-port network completely describes its behavior in terms of the voltage and current at each port. Thus, knowing the parameters of a two-port network permits us to describe its operation when it is connected into a larger network. Two-port networks are also important in modeling electronic devices and system components. For example, in electronics, two-port networks are employed to model transistors and op-amps. Other examples of electrical components modeled by two ports are transformers and transmission lines. So here is one of the parameter, that is a Y parameter. For popular types of two-port networks or parameters are examined here. One is the impedance, the admittance, hybrid, and transmission. We know the usefulness of each set of parameters demonstrate how they are related to each other. So the figure over here represents a two-port network. A four-terminal network is called a two-port network when the current entering one terminal of a pair exits the terminal in the pair. For example, I1 enters terminal A and exits terminal B of the input terminal pair AB. We assume that there are no independent sources or non-zero initial conditions within the linear two-port network. Let us see about the admittance parameter in this video. The network shown in the figure is assumed to be linear and contains no independent sources. Hence, principle of superposition can be applied to determine the current I1, which can be written as the sum of two components, one due to V1 and the other due to V2. Using this principle, we can write I1 is equals to Y11 V1 plus Y12 V2, where Y11 and Y12 are the constants of proportionality with units of Siemens. In a similar way, we can write I2 is equals to Y21 V1 plus Y22 V2. Hence, the two equations that describe the two-port network are I1 and I2. Putting the above equation in matrix form, we will get in this manner. So, the constants of proportionality, that is Y11, Y12, Y21 and Y22, are called Y parameters for a network. If these parameters are known, then the input-output operation of the two-port is completely defined. Equations 7.1 and 7.2, we can determine Y parameters. We obtain Y11 and Y21 by connecting a source, that is current source I1, to the port 1 and short circuiting port 2 as shown in figure, finding V1 and I2 and then calculating. Since Y11 is the admittance at the input measured in Siemens with the output short circuited, it is called short circuit input admittance. Similarly, Y21 is called the short circuit transfer admittance. So similarly, we obtained Y11, as we obtained Y11, we'll obtain Y12 and Y22 by connecting a current source I2 to port 2 and short circuiting port 1. So Y12 is called the short circuit transfer admittance and Y22 is called the short circuit output admittance. Collectively, the Y parameters are referred to as short circuit admittance parameters. Please note that Y12 is equals to Y21 only when there are no dependent sources or op-amps within the two-port network. So we'll see one example problem, that is determine the admittance parameters of the T network as shown in the figure. We've got three resistors connected in the T form. So to find Y11 and Y21, we have to short the output terminals and connect a current source I1 to the input terminals. The circuit is so obtained as shown in the figure. So we will have I1 divided by, that is I1 is equals to V1 divided by 4 plus 2 into 2 divided by 2 plus 2. So our total answer will be Y1 divided by 5. Hence our Y11 is equals to I1 by V1. At V2 is equals to 0, we will get 1 by 5 seconds. Using this principle of current division, we get minus I2 is equals to I1 into 2 divided by 2 plus 2 divided by, which is equals to I1 divided by 2. So similarly, we will be finding out Y22, where Y22 will be 3 divided by 10, that is I2 divided by V2, and our final Y12 will be minus 1 divided by 10. So putting this into matrix format and solving, we'll be getting the answer to the solution. We have another example problem, which is to find Y11 and Y21. Short circuit the output terminals and connect a current source I1 to the input terminals. Resulting circuit diagram is as shown in the figure. So similar to the previous problem, we will be solving this for Y11 and Y21, where we'll be dividing I1 divided by I2, that is 3 by 2, and then using the principle of current division, we will get our Y21 value, which is minus 1 by 2. I hope this video was helpful. Thank you.